Hello guys, Daily Algorithms here. I'm excited to be back solving one more algorithm problem, and today we're gonna solve a very exciting, challenging, and to a certain extent practical algorithm problem. If you like chess, that's the problem for you. And we're also gonna be dealing with dynamic programming, that is often a challenging topic. So I'm gonna go step by step. I have a lot of drawings, a lot of examples. So I hope you guys understand. And if you don't, please ask in the comment section. Also, don't forget to join the Facebook group to have access to our weekly coding challenges, our lives. So stay tuned. So first, let's understand how a knight moves. If you don't know how chess works, a knight moves in a L, in an L shape. So you go two to the right and up, two to the right, up, or you can go down, or you can go up left, always in an L position. So let's go through the problem statement. So we're giving a n by n chessboard. So this is not your regular chessboard with 8 by 8. It can be 3 by 3, 2 by 2. So we have to think about how to solve this problem with a variable chessboard. We're also given R and C, and R and C will represent which spot the knight will be at. And we are also given K moves. So if it's 0 moves, the knight stays where he initially was at. If you have 1 move, as this example shows, he has 8 different possibilities of moving. If it was 2, for example, from here he could go here, he could go here. So the idea of the problem is getting what is the probability that after K moves the knight will still stay in the board. I'll go through an example so you guys can visualize exactly what that means. So LeetCode provides us with an example with a 3, 2, 0, 0. So let's take a look at an example visualizing. So let's suppose, so he says it's 0, 0, and the size of the board is 3 by 3. So we have a 3 by 3 board that I've constructed here, and the knight is at the beginning at this spot. So what happens in the first move? He has 2 possibilities. He can go here, so the knight can come here, and the knight can also come here. And he can come here. Observe that the knight that was at the beginning here, we kind of erase it, and that will be important when I explain how we do dynamic programming in this problem. So you have to always reset the 2D array in order to represent this. So with K equals 2, this knight can come here and can also come here to the top. So he can come here, he can also come here, and this one can also come here. So I'll do 2 times this, and can come here to the bottom. So that's an example of the different possibilities with K equals 2. Let's now think about how we can represent a board. A cool idea, I think the most obvious idea would be to represent the board as a 2D array. And in Python, we have a very cool way of doing a 2D array. We can use something called least comprehension. I'll do a series of videos explaining cool Python tricks that it will be available probably in the next 2-3 weeks. But this constructs a 2D array with n by n, and that will represent our board. 2, 3 would represent this position, for example. So now let's think about how can we go to all the different possibilities of a chessboard. We can go, let's go through an example. So if I'm here, if I'm 3-2, if I'm here, what is the index of this? So we go back 2 columns, so that would be -2. The column would be -2, and we would go down 1, so we would have +1 row and -2. So for every single possibility, we create a tuple. A tuple is just a pair of numbers. We put them in a larger tuple and we can iterate through it. And then we're gonna iterate through the rows, the columns, and for each row and column, we're gonna try all the different possibilities. You guys will understand how it actually works in the end when I put everything together, but I just want to show all the different possibilities, and we will do that k times because that's how many moves we'll have. I'm just breaking down the problem so it's not overwhelming when I present the whole code. So why do we need 2D arrays? So I told you guys at the beginning we're gonna have 2 arrays representing the board, and the reason we will have 2 arrays is because, let's say we start here. What is the probability at the middle of the board? What's the probability after k moves that the knight is within the board? Well, it is 1. You're putting the knight in the board and you're not moving, so there's 100% possibility it's gonna be in the board after k = 0. What about one move? Well, each move has a 1/8 probability of being taken because you have 8 different possibilities and this is one possibility, so you have 1/8. If you add them all together, you have the sum of 1, which represents that you are still within the board. But if you leave 1 here, you're gonna have more than 100%. You're gonna have 2, which is mathematically impossible. So for every iteration, you need to take out the 1 and leave all the other probabilities, right? So you guys will understand what I mean by that when I show the code, but just be aware that we have to reset the board. And as I was saying, if you want to know the probability of staying on the board, you just sum all of the probabilities. And in Python, so this is a cool Python trick. If you like Python tricks, take notes of this one. You can sum all of the values in a 2D array using this expression here. If you don't trust me, go on your Python console, create a 2D array and try this out. Actually, let's do this right now. So let's say I have 2, 3, 4 and 4, 5, 6, let me start this like so. If I do a map, I can do first I put the function, so a map will do something to each item of the list. So in this case it will sum all the items in each list, and we provide which list it is. It's A. So we got sum of A and sum of B, right? And if we want the sum of everything, we just sum this list we got. So we can do sum A, and we get the sum of everything. So just a really cool trick that can come in handy in an interview. So now let's take a look at the actual code. So here's the code. We are initializing a to the array, and we put 1 at the first spot, and that's dynamic programming is using past computations in future computations. Without that, look how many for loops we have. It would be very inefficient. So dynamic programming gives us a way of making our code run more efficiently. We're gonna create a second to the array, and then we're gonna iterate over each row, each column, try all the different moves. And this is important. If it's within the range of the grid, because if it's not, then we're not computing the probability. It has to be within the board. We're gonna take the value and divide by 8. So in our example, we got 1 and divided by 8. That's what we're doing here. Divided by 8. And then we assign it to the outer to the array. And then in the end, we just sum the probabilities we've calculated. What if we don't do that? Let's take a look at the code. So let me quit the console. Let's run this code. So right now we're getting 0.625, which is what we expected from the example. But what if we just use DP, the outer loop? Let's take a look. Let me see. So we get these crazy values, and then we get over 100% probability, which is impossible. And that's because we're not reinitializing. We have to erase this for every computation. And then we just have this 1/8, and then we'll have to erase this 1/8 and just have the probabilities, and then we add the now up. So this is a really cool problem. You have to use dynamic programming. You have to think about a little bit of probability. You use some cool Python tricks. So I hope you guys enjoyed the solution. I try to make more pedagogical. I think I've been just talking through the problem and not being very clear in the last video. So if you like this video, just give me a thumbs up, join the Facebook group, and I hope you guys stay tuned for more algorithms. Cool interviews are coming with some very good developers, and also my Python trick series that is coming up. So thanks for listening, and let's